In the world of high-performance software, there's this huge debate going on right now. It's really a story about a king who's been ruling for over 40 years and a powerful new challenger that's coming for the throne. We're talking C++ versus Rust, and this isn't just some nerdy squabble. It's a battle of philosophies that could seriously define the future of the code that runs, well, pretty much our entire world.
To really get this, you got to start with the philosophy of the reigning king, C++. And who better to hear it from than the man who created it, Bjarne Stroustrup. This quote right here, it's everything. It tells you that from day one, C++ was built to put power first. It trusts the programmer, completely. It gives them total control, even if that means leaving in features that are, a little dangerous. That freedom is its greatest strength, but as we're about to see, it's also its greatest vulnerability.
All right, so let's properly meet the first character in our story, C++. For decades, and I mean decades, it has been the undisputed king of performance. It's the language behind the fastest, most complicated systems you can possibly imagine. And just look at this timeline. It really shows you the sheer staying power of C++. This is not some dusty old relic. It's a living, breathing language that has been changing and adapting since 1983. From taking over the world in the 90s to getting huge modern updates in the 2010s, it is still at the absolute cutting edge, with massive global conferences like CPPCon pushing it forward even today.
Okay, and this slide, this just lays out the core conflict perfectly. On one side, you have C++, which basically says, hey, I trust you, the programmer. Performance is everything. You handle the memory. But then Rust comes along with a totally different take. Whoa there, let the compiler help you out. Safety is everything. We're going to enforce memory safety so you literally can't make those critical mistakes. This right here is the fundamental divide we're going to be exploring.
But, that whole C++ philosophy of programmer freedom, well, it comes with a pretty big price tag. For decades, there's been this hidden flaw that's been responsible for just a huge number of security problems and system crashes. So let's talk about the high cost of all that freedom.
And that flaw has a name, memory unsafety. So what is that exactly? Well, to put it simply, it's when a program accidentally messes with a piece of the computer's memory that it's not supposed to be touching. Now, this can just cause the program to crash, which is annoying, or much worse, it can create a security hole that hackers can get through. This is the technical problem at the very heart of this whole debate.
And look, this is not just some abstract, nerdy problem for programmers. It has massive, real-world consequences. In 2023, Consumer Reports, the same people who review your toaster and your car, they published this report. They basically reframed memory unsafety as a consumer safety issue. That's when you know this thing has gotten really, really serious.
So, now that we've established the problem, the stage is perfectly set for our challenger to walk in. Enter Rust, a modern language built from the ground up to preach what you might call the gospel of memory safety.
And you got to understand where Rust came from. It was created at Mozilla, the company behind the Firefox browser, with a super specific goal: to be a better C++. The whole idea was to give developers all the raw power and performance of C++, but with one game-changing promise: guaranteed memory safety. So how on earth does Rust pull this off? It's through its most famous and revolutionary feature, the ownership model. And it's enforced by something called the borrow checker. Let's break it down real simple. First, every single piece of data has one and only one owner. Second, when that owner is done with it, the memory is automatically cleaned up for you. And third, the compiler acts like a super strict librarian. It enforces all these rules about borrowing data to prevent any dangerous situations. If you break the rules, your code just won't compile. Period. Now that's the trade-off. Learning these rules is famously tough, which is where Rust gets its reputation for a steep learning curve. But the payoff, as you're about to see, is absolutely immense. Okay, that all sounds great on paper, right? But does it actually work in the real world? So let's head over to the proving grounds, Google's Android operating system, one of the biggest and most complex code bases on the entire planet. The results from Google's experiment are, well, they're staggering. The bottom line is this: for new code written in Rust, they saw a 1,000 times reduction in the density of memory safety bugs compared to the C and C++ code. Let that sink in for a second. 1,000 times. That's not just an improvement, that is a total game changer.
But it's not just about security. It turns out that Rust code was also 4 times less likely to be rolled back. That's just a fancy way of saying the new code they shipped had way fewer problems and was much higher quality from the start. Basically, the code just worked better the first time.
And finally, all that strictness from the compiler pays off in pure efficiency. Developers were spending 25% less time reviewing Rust code. And why is that? Well, because the compiler had already found and stamped out an entire category of bugs before a human even had to look at it.
And if you're a visual person, this chart just says it all. Back in 2019, Android had 223 of these critical memory safety bugs. After they started using more and more Rust, that number just plummeted. By 2024, it was under 50. The data really does speak for itself. So that's it, right? Case closed, Rust wins, C++ goes home? Well, it's not that simple. The reality is actually way more interesting. This isn't a simple replacement story. It's more like the beginning of a very uneasy coexistence.
Because the old king is not giving up its throne. The C++ community is as alive and kicking as ever, and the language itself is evolving to fix some of its own weak spots. They're adding major new features like modules to make code easier to manage, and they're working hard on making those infamous compiler errors a lot more friendly and helpful.
Which leads to this really interesting idea. Maybe the future isn't a battle at all. Maybe it's a team-up. The two ecosystems are actually starting to build bridges. There are libraries, like one called CXX, that are built specifically to let Rust and C++ code work together safely, side by side, in the exact same project.
So as it stands right now, here's the lay of the land. C++ is still the absolute king in places with gigantic existing code bases that are just too expensive to rewrite. Think big-budget video games and high-speed financial trading systems. Meanwhile, Rust is becoming the clear go-to choice for brand-new, security-critical projects, like parts of operating systems, blockchain, and the next generation of the web.
And all of this leaves us, it leaves you, with a really big question to think about. In a world where software controls everything from our phones to our cars to our medical equipment, what do we value more? Is it the absolute freedom to build anything we can possibly dream up? Or is it the guarantee that what we build is fundamentally safe? The answer to that question is what's going to shape the future of code.